All right, good morning, guys. I'm Jason Conger. Brandon Shell will be here in just a minute. He's still doing some booth duty. So what we're going to do is I'm going to start out the presentation, and then we'll have Brandon come in here in just a few minutes, and he's going to do the tail end of the presentation and show you what some cool apps that we're doing here with Splunk. All right, so again, welcome to the sponsored session by Splunk. And the agenda for today is really just two things. The very first question that most people ask is, what is Splunk? So, you guys ever heard of Splunk before? A couple of people? So, fair question. So Splunk's been around for a while, been around over 10 years, and Splunk really made its name in the syslog and security type sector. So Splunk is relatively new to the desktop virtualization sector in the past 3 years or so. So the fair question, what is Splunk? So hopefully we're going to clear up that question today. So what is Splunk? So we'll cover that. And then the next section that we'll cover is what is a Splunk app? So there's a difference between what Splunk is and then what a Splunk application is. Okay, so we'll get started with what is Splunk. Okay, so the technical definition taken right off the Splunk website is Splunk is the engine for machine data. And so everybody knows what Splunk is now, right? Yeah, what the heck is that? What is the engine for machine data? What does that mean? Well, the engine for machine data is a lot of enterprises generate a lot of data in their environment, and a lot of it is largely untapped, meaning you're not getting value. So there's a lot of things creating logs, there's a lot of outputs from scripts, there's a lot of just syslog data, just all this type of data that is just largely untapped in your environment, and there's a lot of value in there. So the founders of Splunk, they go to people and say, how are you troubleshooting things? How are you actually going in and looking through your logs? And if you ever try to go look through a log yourself, just manually read it, a lot of it is just really hard to read. It's very verbose, it's very terse, it's very hard to read and figure out what's going on. So you can think of Splunk is, going back to the definition, Splunk being an engine for machine data. You can think of, your favorite search engine goes out there and indexes web pages. So when it comes time to find what you want, it's very quick and easy to find what you want. You take that same paradigm and you turn it into machine data. Splunk indexes machine data. And when it comes time to figure out what you want, if you're either doing a troubleshooting exercise, or you're trying to do some kind of monitoring, some alerting, or you just want some visualizations for dashboards, help desk, you want to give your management some type of dashboard what's going on in your environment, usage, so on and so forth, Splunk gives you the ability to do that because now your data, your machine data, is indexable and searchable, and so then you can go build your visualizations on top of this data and find what you need in your environment. So this particular slide right here shows that all types of systems are generating machine data, and the machine data technically is one of the fastest growing and most complex types of data to get in your environment. So the problem with machine data is it's not structured data. There's not like some database that's going to define some schema and everybody conforms to that. No, everybody does their own thing with their machine data, and there's no like standard for it. So Splunk solving a problem with some unstructured data is a very, very ingenious thing. Okay, so what makes, I keep talking about this unstructured data, what makes it different? So traditional relational databases, things like SQL Server and Oracle and things like that, they have a schema, and they're based on a schema, which means they're not flexible. So if you want to come pipe in some data into a SQL database, you're going to have to do some kind of connector to get data from one format into another format in order to put it into a database. Now, multi-dimensional databases are really cool. They're really great for statistical data. These are really called cubes. So you've heard like a OLAP cube, thing like that. That's really good for large amounts of data. That's very statistical, but you're still stuck into, you're not very flexible. So then we get into this machine data. It's unstructured, and it's really time based. So event comes in, all your events, normally they have a timestamp. They have some data after it and a timestamp and some data after it. That's the kind of general rule of thumb for most type of logs. Okay. So Splunk's architecture, the way that Splunk works, the heart of Splunk is what's called the Splunk indexer. And that's this second little line right here. So again, I said that Splunk is unstructured data, and Splunk is not a database, but Splunk does have data storage. So data does come in, it's stored somewhere, and then that's where Splunk does its indexing power. Now there's also something that sits on top of the indexer, this very top block here. This is searching and reporting. When I get into the demo in a minute, the user interface is actually what you'll see, and that's the search head is what we call it. And then you have this, this management for deployment server. So once we get in a little bit more of the architectural, you'll see that there's the indexer, and then there's agents that are sending data in. There's syslog that's coming into Splunk. There's several ways that data gets into Splunk, and you need some centralized way to manage how data is getting into Splunk. You did this with your deployment server. And then, like I just mentioned, you have ways that data gets into Splunk. That's these, what we call forwarders. You can think of that as an agent. So basically, a forwarder is just a dumb piece of software that just sits there. If you don't tell it to do anything, it doesn't do anything. So you have to tell the forwarder what to do, meaning go grab this event log, go grab, look at this file, go look at this perfmon data, go run a script, and the output of that script forward it over to data, over to Splunk, so on and so forth. So that's the last piece. Now, these roles are all logical roles, meaning they can all exist on one server if you want, and then you can scale that out. So as you scale larger, you can separate these roles out into multiple boxes. So right now, I'm running all of those roles right here on this single laptop. So it's a Mac laptop. It's running Splunk. It has data. And as you can see, actually this piece right here with all the graphics, that's applicable to any of these roles, because it doesn't matter what platform that you install Splunk on. Splunk will install on Mac that we have here. It'll install on Windows. It'll install on Linux. We have instances running in our environment that are going CentOS, it goes HPUX, so on and so forth. So that being said, you can start out very small in an environment, get Splunk in, figure out some things to do, and then if you need to grow to, we have clients doing terabytes of data a day. Terabytes of text data is a whole heck of a lot of data, and so naturally that scales out. So you can scale out your indexing or your searching and things like that. I said you can start very small. If you go to Splunk.com, there's this nice big green button in the top right, free download. That free download is actually a free instance of Splunk that allows you to index up to 500 megs of text data in a day. Totally free forever. If you never go over 500 megs of data in a day, you never pay anything. Splunk is a platform, and that's what you're downloading when you're downloading Splunk. You start going over 500 megs of data a day, then you start getting into paid instances of Splunk. And again, Splunk's a platform. When Brandon talks about apps in a minute, the apps that sit on top of the data, and we'll get into what an app is in a minute, the apps themselves that sit on top of the platform, those are totally free and they're open source. And so a lot of times people will say, that's a really nice app, I like what you did here, but I'm going to tweak it a little bit. No problem, you can do that. The app's open source, free. Okay, so like I mentioned, we have this concept of forwarders, and you got to get data into the Splunk index somehow. So how do you do that? So there's several different ways. So some things support syslog right out of the box. For instance, NetScaler supports syslog right out of the box. You can just go and configure NetScaler, say send a syslog to Splunk, you're done, there's nothing else to do. You get into a more complex environment, like a Zen desktop environment, then you're getting into installing some of these forwarders. Now we pre-package, like I said, the forwarder itself is really dumb. It doesn't do anything unless you tell it what to do. But we pre-package these forwarders to say, here's what you should do. So we give some best practices on this type of data to collect. So say, on Zen Desktop, we have an agent that goes and installs on top of the broker, and it will collect information from the broker. It will have information collected from the VDAs, and that's and then I guess hypervisors. And you got a house mic. What else are we collecting with Zen Desktop?
We collect from the DDC. We collect from the VDA. Those are the two endpoints that we collect from. But we can also collect NetScaler data, hypervisor data. If you have EMC or NetApp, we can collect data from there, and then correlate that back to the user.
Right.
So,
and again, like I said earlier, the cool thing about this, Splunk doesn't know what data is coming in. Splunk doesn't care what data is coming in. There's no upfront schema. There's no connectors. There's no relational database, because Splunk doesn't care. You just throw data at Splunk, and it will go and index that data and start to give you some smarts about that data, as we'll see in a live demo in a minute. Okay, So like I said, Splunk is a very scalable architecture. Splunk can scale across the data center. So you can have some indexing and searching going on here. One instance of Splunk doing the indexing and the searching, and you have multiple types of forwarders, a Windows forwarder, a Linux, and Solaris. They're all sending their data to Splunk. So you can start out with just one single instance of Splunk running somewhere, and a lot of forwarders forwarding data to Splunk, which is what I have on my laptop here. Now, if you start to outgrow that architecture, you can say, I need to offload some of my roles here. So I have multiple Splunk indexers, and I have a search head up here. You can actually have multiple search heads. So you're grabbing a lot of data, so you need to scale it out. No problem, we can do that, and it's actually built right into the box. There's no load balancers that you have to configure. It's just really just go into Splunk, configure it, say here's another indexer, boom, you're done. And then, of course, forwarders sending information over to Splunk. Okay, if that's not scalable enough for you, if you need to go, oh yeah, I'm sorry, I'm getting ahead of myself. So the way that this is done, where you have multiple indexes, are indexers right here, and then you have indexes in your indexers. The way it's done to make everything fast, it uses what's called a MapReduce technology. Now MapReduce was first, it's really a framework that's introduced by Google, and you can think of it in, the way I think of it at least, is in a Windows world you have processes and they spawn threads, and so you can think of it as a search will go spawn another search over here, and over here, and then unlike, a thread can't spawn another thread in Windows, but MapReduce it technically can. So what happens is that search keeps going out and it keeps expanding over, and then so the search will happen here, and it will say go run these searches, and those searches can run searches as a kind of a pyramid type scheme here, and then they start to return the results up to the master search that started everything. So it actually makes the searches extremely fast. All right, so we were going over, so you have in your enterprise, you have one instance of Splunk and a lot of things coming in, or you have multiple instances of Splunk indexers to scale out, because if you're getting into terabytes of data a day, you need to scale out. Now also, you can scale to multiple data centers. So you have New York, Tokyo, London here. Each one of those data centers can have a scaled out architecture. And if your home office is somewhere, you can have a headquarters up here at the top that can run a search using the same MapReduce technology over all of those instances. So you can keep data local, so you can have this data here stay local and not traverse a WAN link. Same with here, and each one of these could be kind of like a franchise type scenario here, where they have their data, and you have headquarters that can go plug into all of those instances as well to run its search against there. So you can, actually I was talking to somebody earlier about if you have India and you don't want data traversing the line up to India, you have your search head in the US, India data down here, and run your searches across this. So it's very, very scalable architecture. Okay, so here's what we go. Now, this is kind of a architecture slide, so sorry, there's still some architecture in here. Typical day in the life of a very large enterprise where you have multiple teams doing things. Guy calls in and says, my stuff doesn't work. It's like, all right, well, the desktop group says, well, it's a virtual machine, so you need to talk to Citrix, the Citrix team. And the Citrix team says, well, yep, everything looks good on my end, but you need to talk to networking.
Because it's always networking.
It's always networking, every time. Every time it's networking. So the network guy says, yep, looks good to me. Of course, nobody's ever going to find fault. So it must be a VM. And so they go talk to the virtualization group. The virtualization group says, a VM's up, everything's good. It must be a storage person. So the storage admin says, yep. The storage guy says, yep, I see fault here, so I'm going to take care of this problem for you, and the problem's fixed after however many hours. You started at noon here, and here we are, oh my goodness, like 8:30, so 2.5 hours worth of time just passing the user around, and the user is frustrated, and here we go. Okay, so if you have all your data in Splunk, the person taking care of this can say, all right, let me go find this IP address over every single log that's come into Splunk. And again, Splunk doesn't know what kind of data is coming in. It doesn't care. It just go look for that IP address in all the entire data set using that MapReduce framework there. And it says, all right, well, let me add some more. Let me find failure or error, just drilling down more into my results. Then I'll say, hey, find it where the user ID is John and there's a permission change. And then you can also see that we're drilling down not only on the search bar, but also in the time range that we're drilling down. So here's our clock now, noon to 10 minutes later, and we figure out what's going on versus the hours.
Yeah, the important thing to note about the slide prior is that it really only took 5 minutes to fix the problem, right? It took 2 hours to find the problem, which is your typical,
Right.
it's the way it typically works, is you spend so much time just trying to figure out, it's the not me syndrome, or, they have a whole bunch of different terms for that. But once you find the person, it's normally not a long, it's a very short time to resolution once you get to the endpoint. So if we can shortcut that whole process and give you a user-centric view of each layer, the network layer, the virtualization layer, and the storage layer, the help desk or whoever the entry point is, can immediately look at the graph for the user and say, oh, it looks like a storage problem, let me start there, as opposed to going down the list of, it's like you call the cable company with a problem, and they go through this whole script, and you spend 3 hours, and you even know what the problem is, but they don't want to hear it, right? They want to go through their script. So we can bypass that whole process and say, you know what, it looks like a storage problem, let me call the storage team, and you get that 5-minute fix as opposed to that 2 hour and 5-minute fix.
Okay. And again, more architecture slides, but it is relevant. So again, because Splunk is, as you'll see here when we start to build an app from scratch, Splunk by definition is technically all ad hoc. So we have some pre-canned apps that give you a lot of visibility, turnkey solution, but all of these apps were created using the Splunk search language, which we'll go over in a minute. So if you need a report, you don't have to go to a vendor and say, I need you to do this and get this in your product because I have this very specific thing that I need just for me. It's all ad hoc. So Splunk allows you to do your search queries, build visualization report, no problem. We have that built in there. And if you need to see it in real time, Splunk has real time and historical, so you can see data as it's coming in real time, or you can look back as far as the data that you have stored. And then, like I said, you want to see it over the last year. If you have that data on disk, no problem. Also worth stating that the way Splunk is licensed is how much data comes into the index environment in a single day. I mentioned earlier the free download, 500 megs of text data coming in a day is totally free. You start going above that, you get into a licensed product. Splunk is not licensed on how much data you store. So if you want to store 10 years of data, great, I don't care, no problem. You have to have the storage infrastructure to do that. And now Splunk does have some built-in features to where if you want to start rolling off some of this storage, as you have hot buckets and cold buckets and warm buckets and things like that, so you can start rolling data off to have really high-end storage for stuff that you need right now in the last 2 weeks, and then maybe roll it off into some cheaper storage and roll it off onto some cheaper storage, even if you want to go cloud or tape or something like that. Yeah, no problem. Whatever the operating system can see, Splunk can store it on there.
Yeah, another important note about this particular slide, or at least the point of the slide, the other thing that you'll also find is you have different types of people in your company. You have different types of people that want to look at the data in different ways. They want the same data, but they don't want to look at it the same way. For example, the way that your IT pro or the guy that the admin is looking at the data is going to be different than the way the help desk would look at the data, which is going to be significantly different than a manager of operations is going to look at the data, which is going to be even more different, or differenter?
More
Whatever.
different.
Is even more different for like the CEO. So what Splunk do, since we don't chop the data and we don't process the data at consumption, all the data extraction and all that stuff's done at search time, you could easily create reports on the same data for each branch of the government of your business without having to worry about saying, oh, well, now I need to do a different SQL extraction for this and a different SQL query for this. You can actually use the same dashboards or the same searches and just tweak the dashboard for whoever you're trying to consume the data for.
Okay. And okay. So again, we have, to add on to what Brandon was saying, there's kind of the life cycle of the data here. We have the collection, we're searching, which you have real time. You're adding the knowledge, which you can start to teach Splunk about certain types of data. You can do monitoring and alerting, so there is built-in monitoring and alerting with Splunk. So everything technically is a search. So you can say, there's this search that runs, and if you find this condition, let me know. Very, very flexible, but also what's cool about that, since it's just all data, is not specific to any one thing. You can say, start the search here if there's a problem here, and go on and drill on down, and if it's here, you can let me know along the line which piece it was as well. And then the report and analyze, that's where we're talking about the dashboards and the reporting. And like Brandon just mentioned, you can have different reports for different areas to your business, but it's all based off of the same data.
And also important to note about this is that we don't, and it's actually very important, if you ever get into where you're actually trying to fix stuff, understanding that we don't change the data that we consume. We don't touch it, we don't chop it up, we don't do anything to it. We just index it exactly as it comes in. And that's important because when you actually need to troubleshoot something and you actually need to get to the data, you want context-sensitive data. You don't want data that's been all chopped up. So we store the message just like it came in. So if you have a syslog message or firewall message or server, whatever you're trying to get the data from, we store that data just like it came in, and you don't have to worry about losing any data. And you can build context. You can do searches where it shows you events before and after and that kind of stuff.
Right. That's a good point. Thanks for reminding me of that. Okay. So this is really just kind of a review. So again, we've already talked about the indexing, and there's no data normalization, meaning we're not trying to fit some schema. And then we're really going in, we're not changing the data, like Brandon said. We're just looking at the data as it comes in and doing some intelligence on top of that. That's the late structure binding. So when data comes in, Splunk is going to do some intelligence for you and start picking things out to make the searches easier for you. And then the analysis and visualization to where we can start building the dashboards on top. Okay, again, what makes Splunk different is any data, it doesn't matter. Any kind of source, any kind of, since it's unstructured, just anything coming in. Flexible, and you get your results. So, like again, I mentioned free download, installs on any kind of platform, and you'll see the out-of-the-box experience and how you can start getting value out of your data immediately. Okay. So again, summary key points. So this is cool. You guys heard of SMS passcode before? It's a two-factor authentication mechanism that uses SMS. It's kind of dark. It doesn't show up very well. So they're using Splunk. And what they're doing is, you can see, this is actually, can you guys see that?
Looks like a black screen.
That's actually a map. That's a Google map. You can see it down here. It's a Google map.
Of what looks to be Europe.
Yeah, it is Europe because they're a European-based company. And so what they're doing, they're taking their log data, and the guy that did this just did this in a matter of hours. Like, there's a Google Map plugin for Splunk, and he mapped out where successful and unsuccessful login attempts are coming from. And so at this big red dot, that was a lot of unsuccessful login attempts. You can drill down into there and see, drill down even farther. The zooming feature of the map works, and you can drill down and see what's going on in there and see where they're coming from, and then can do some reaction to there, maybe shut off access to that particular area of the country. That's a pretty cool use case, I thought. Okay, so enough slides. Let's do some demo.
While he's getting that set up, any questions that we can answer so far?
Okay.
So you've either done a really good job of explaining it, or they just don't care.
They don't like architecture slides. So.
What toolkits are there for application plugin?
So we have several
Repeat the
SDKs
question.
that you can get. So the question was what toolkits are available for application integration. There's two different parts to that. There's the part where you just want to get data into Splunk, right? And then the way that would work is you could either write your own, like what they call a scripted input. Like you could set up a CentOS or whatever version of Linux or whatever version of OS that you prefer. And this is exactly how we do the Zen server data right now. And then you install the universal forwarder, and you just tell it to run a script every X amount of seconds. And it does the connection to REST or SOAP or whatever.
Yeah, the Zen API on that for Zen server. Yeah.
So the Zen API extracts it. So that's one way. We actually have a whole set of actually SDKs. So you can actually build an entire application or product on top of Splunk without using Splunk Web. So we have a Java SDK, we have a JScript SDK, Python. We're working on .NET, and we have a PowerShell. So there's that way if you want to build on top of actual Splunk. The .NET stuff is going to come much faster than it was initially planned, since I'm paying for it. We had another project that required it. So I would suspect that should be out in the next 2-3 months. But if you're interested, I can get it to you quickly. It's actually just a It's just a REST wrapper, really. The REST API is fully functional, and it's actually how all the SDKs communicate with Splunk is through the REST API.
I'm kind of interested in if you could check Splunk up in Azure and then do all the cool stuff.
Yeah, so we actually have Splunk, what we call Splunk Storm, which is our kind of our software as a service implementation of Splunk. So it's all cloud-based. I think it's based in Amazon. But, I mean, there's nothing to say we couldn't make that work or something similar like that to work in Azure. So it's obviously a little different story, right, because Splunk is IOPS sensitive, right? It has to do a lot of input-output operations, obviously. So depending on the size of the data, we should talk about it. It's definitely possible, though.
So you use the AWS to do implementations for that?
Actually, I don't know how the Storm guys do it, so.
Oh, you just run this? Oh,
You can actually run Splunk in an instance if you wanted to, but we actually have Storm, which is a multi-tenant design that we came up with. So you just, like, you sign up for it, you say, I want to use it, this is how much disk space I want to, this is how much index, they don't care about disk, this is how much index I want to do a daily, and they give you an IP and a port, and you send away. And then you can build all your stuff on top of that. Any other questions? I guess you can.
Okay.
We'll have plenty of time at the end for questions, so. No.
No worries.
I asked
That's good.
if you had any questions. It's a good time to answer.
Yeah, absolutely. So this is what Splunk looks like right out of the box. So whenever you install Splunk, this is, and you go to the URL that you're done installing. It says go to this URL, which is whatever you can see up here. The URL is my MacBook port 8000. So it says go to that URL, and this is what you see. So what we're going to do, the default app out of Splunk is search. What this is showing us, you can see the search bar up at the top, but it's showing us all this indexed data. So we can see data is coming in right now to my instance of Splunk because I have it indexing parts of my laptop here. So this is everything. Now, I have some generated data on here that is from Active Directory and Exchange and NetScaler and Zen Desktop and Zen App, all kinds of good stuff coming in. So this is everything. So if I wanted just to, up here in the search bar, type error, it would go find the word error in every single piece of data that I have. So it could be anything.
I should specify, by default, it actually only looks in the main index. So if you want to, you can have as many indexes as you want. And we actually advocate creating app-specific indexes. So you'll see when we do our Zen App stuff, we have index equals Zen App or index equals Zen Desktop. But when you just do the search bar, by default, it only searches the main. So
the reason for doing multiple indexes is
data isolation is pretty much the only reason. It makes it easier to create searches based on that.
And also, you can have different policies for different indexes. So if you have a different retention policy for your Zen App stuff, or you want to roll
And
with
access-based.
Right.
You can actually do access-based roles. The question was, by the way, I always forget to do this. The question was, why would you have multiple indexes?
Yep. So that's a good cue up to say we want to look at just our Zen App data. So can you guys see that, by the way? That's kind of small, huh? I probably should change the screen resolution.
Yeah, it's control plus 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 or function or something like that.
I don't know what it is.
That's why you have a Mac, man.
There. I am on a Mac.
That's what I'm saying. That's why you have a Mac.
Okay, so basically what I'm doing, like Brandon just said, is like, I want to just drill down into my Zen App data. So here we go. So what happens now is...
That's a little too big.
It's a little bit too big, yeah.
One thing I do want to, so he'll show you this as, one thing that's really cool about Splunk is that it kind of educates you about your data as you go along, right? So we knew index equals Zen App, and as he was typing index equals, Splunk was saying, all right, so here's are some of the indexes that you actually had. So you could actually just click that. And now when we go into the index, down here, which you can't see just yet because he has to scroll down, you'll see over here where it says selected fields. It'll educate you about some of the data extractions that it's already figured out. So it sees in this data, some of the instances is there's farm name, there's machine name, there's server name, there's all of this stuff. And actually, there's 120 other fields that we've found in the data, which we haven't told Splunk anything, right? It's just looking at the data and says, these look like valuable fields. So if you go to the top, you have the host, the source, and source type. So if we want to look at something like server load, you can actually just click source type.
Yeah, I got it. Go ahead. We're going into what I want to show first is every one of these lines here. You see the date timestamp. That's the raw data coming in, and there's different source types here. the output of this is really a PowerShell script that's going in on some of these. So this is the raw data, like Brendan mentioned earlier, that we don't do anything with the raw data. We don't change it. So this is
exactly what we sent to Splunk.
Yeah, so this is not very usable though, because again, we're into the point of we're having to read all this stuff manually. So like Brendan said, we want to, everything is broken up into source types. So this is all our XenApp data. If we just want to look at server load data, which server load, if you go to a command prompt on a XenApp server and you type qfarm/load, it'll show you all the servers in the farm and some arbitrary number. That number is actually how busy the server is. Some of them mean certain things, like 10,000 means fully loaded. It's not going to accept any more connections. But basically based on the type of load evaluator you have, whenever the person comes in, the least loaded server is going to get the next connection. So let's look at our server load data. And again, we're drilling down in the data, but again, we're still not very usable on what we're seeing here. But we're getting there, so that's pretty nice. So what we can do here is let's pipe another command into the Splunk search language. I want to type a table, and I want to say maybe I want to get the server name. And you can see what's happening here as I type. It's saying, hey, here's some interesting fields you might want to add to your search. Again, this is all happening in real time. There's no schema. Splunk's figuring this out while you're doing it. So I was like, hey, I want to get the farm name, and maybe I want to get the load as well. So I do all that, press enter, and now I have a nice table that shows me server name, farm name, and the load. And I can say, hey, there are some servers that are hitting the 10,000 mark, meaning fully loaded. So we're getting better. We're getting a little bit more usable information as we're going here. But let's do something really nice because we want to impress our boss, and let's do a nice pretty graph. So I can do this thing. I want to do something called a time chart. I want to get the average load, and I want to get it by server. So what happens now is Splunk's going to go do its cool search, and not quite what we expected. We thought, well, I did this time chart command, why don't I have a chart? But since I did use the time chart command, there's this cool little button here that instead of showing me everything formatted out, oh, line was good. So it's going to actually graph. Oh, that's a pretty messy graph. But it's going to graph.
Extremely useful, right?
Yeah, extremely useful. Maybe I just want to see, it shows by default, it shows a number of servers and it groups everything into other. But say maybe I just want to see 5 of those servers. So there's actually some more parameters I can add to this command here. Limit equals 5, and then use other equals false. If I can type, not user, other, use other. All right, and go to our nice graph here. So a little bit more usable now, so I can just see my top 5 in a graph. All right, so that's great and everything. I did this search, but what I really want is to make this as a dashboard for my manager to come in and see and give him some nice views into the environment. So what I can do now is say I just want to go over here and say I want to create a dashboard panel out of this nice search. And so I said give the search a name. I'm going to say server load. And then the search string, it just took what I was typing earlier and added that to the search string, and then it gives you a time range. The negative 24 hours, so it goes back 24 hours on the hour to now. So that's the search. Then it asks me what dashboard do I want to put it on. Well, I don't have any dashboards right now, so I'll just create a new dashboard called BriForum. And then I want to click next. And then it gives me, when you'll see the panel, I'll give it a title and the visualization and all this. And then I'll click finish. It says it did the dashboard for me. So I can click that nice dashboard. So now when my boss comes in to this link up here that I give him, he'll have this nice panel. I was like, all right, cool. So now I just gave him some usable information out of all this machine data I have. So it's making my machine data valuable. Okay. So now let's go back to the search that we were doing. And say maybe I want to get some information about some applications. So let's get into our XenApp index. And this time instead of source type server load, maybe I want to do source type sessions because I want to see what our popular applications are out there. So I want to say, all right, I want to do source type. And again, Splunk is doing a lot of the auto completion stuff for me. So I could say, here's some source types down here, and say maybe I want to get, well, type equals XenApp, and then I'll have a session right here. Okay, so again, we're dealing with the same things. We're not very usable data, but really what I want to see is I want to have a nice chart, and I want to do the count by browser name. What this is doing now is I'm creating a chart. This is not a time chart because at the end it's going to be a pie chart. But what I'm doing is the count, which is the number of events in the row, and I'm going to group them by browser name. So if you know anything about the XenApp API, MFCom, or PowerShell, one of the things you get back is called browser name. That's the actual name of the application you would see when you open up the receiver or your web interface or something.
The application name would just be silly.
Okay. So anyway, so we have that. So we have the count by browser name again. Not quite what we do have the browser name and the count, but I said do a chart. So I'm going to click on the chart button here. And unfortunately, this is generated data. So
Very consistent. Like all our apps are used exactly the same amount.
in a real environment, this should be a little bit nicer pieces of pie. But since this is generated data, and I'm responsible for generating the data, sorry about this. So actually, every app was launched exactly the same number of times. But anyway, it shows you how you do your chart. And we do have, again, the same things over here. If I want to do a limit equals 5, I can get just the top 5 apps. Oh, I don't have the split by calls, sorry. And we'll stick with that one. So now if I want to take this nice chart and put it on that same dashboard that I did earlier, I could just say create a dashboard panel. And then again, this will be the app usage. And by default, it gets my search for me again. And now at this time, instead of putting it on a new dashboard, I'll add it to an existing dashboard that I've just created, that BriForum dashboard. And keep that there. And successfully created that. So now when I go to my BriForum dashboard that we created earlier, we have our server load at top. And lo and behold, we have our nice, pretty pie chart at the bottom. So again, this is
Show them the edit button too.
yeah, I am. So this is really cool, but maybe I want to do some layouts, and you would think maybe I have to go into the source code to do some layouts. Nope, we have this cool edit button here that makes everything drag and drop. So maybe I want to have this. Sorry, everything's big here. It's hard to figure out. Maybe I want to have everything side by side, and maybe I want to change the visualization on this instead of a line chart. I want to have some kind of area chart instead. So I can change the visualization on this on the fly. What's that?
I was going to say do stacked, but that's fine.
Do that and say line, now say area. Scroll down here, save. And so there's my nice area chart. I'm done editing. And there we go. I have a new chart. And everything, all the visualizations here have the mouse over capabilities to give you more information about what's going on as well. So I just created a dashboard panel, a nice dashboard for my manager to have his view of the data. Here's the server load and the app usage. You could do on this. And then like Brandon was saying earlier, maybe I want to do a different visualization for if I want to do some kind of chargeback, I could have some kind of different dashboard for that. Or if I really wanted to get into to the IT Pro, get some more information about that, like server utilization versus usage. So all the data is there, just depending on what you do with the data is up to you, and we give you the tools out of the box to do that.
And as you can see up there, you can schedule PDF delivery, so your executives or managers or whoever don't actually have to go and run the reports or do anything. You can actually say, look, they want to have this report every day, so schedule a PDF report to happen every 12 hours, 24 hours, or whatever, and send it to this email address. You can even send it to yourself first so you make sure all the data is right. So you don't have to worry about even saying, hey, manager, come to this URL. Although if the manager wants to see it real time, he wants to see what's happening right now and not worried about what happened in the last 24 hours, he can go to the report directly.
Right. And then also, it's important to note that these charts, they're actually what's called scalable vector graphics, which means that they're not Flash-based, which means it's all HTML5 compatible. You can view it on your your iPad, your Android, whatever. So no Flash, no problem. We got you covered there.
Although if you are a masochist and you want to use Flash, you can.
You can.
We do support using Flash.
Yeah. Okay. So any questions on just, Splunk out of the box, doing some searches, visualizations, things like that? Nope. Okay. Back to slide deck then. Okay. So that was just a demo, and that was just base out of the box functionality of Splunk. So the next thing that we're going to talk about is what is a Splunk app. So a Splunk app is basically everything I just did, but just packaged up together. So if you go, actually let me pop out one more time here. One of the cool things about Splunk apps is Splunk, the platform, is what is the paid technology. Splunk apps themselves, are totally open source and totally free. So if I go over here to my default instance of Splunk, sorry, I don't have an internet connection here, but you can go over here and say find more apps on your default, and this will take you to a website called Splunkbase. And you can think of Splunkbase as like an app store, kind of like the Apple App Store. You have all these apps. You go find the app, and there's like an install button, and it'll just bring it on down. And what an app is, as defined over here on the slide, is just really a collection of all the forwarder inputs, meaning, like I said earlier, the forwarder is really dumb. It doesn't know what to do unless you tell it what to do. So an app will tell the forwarder what to do. A collection of searches. You saw me do some searches. It already has a bunch of canned searches for you. Dashboards. You saw me create dashboard and dashboard panels. It has a lot of dashboards already for you. And then knowledge objects. Those are things like field extraction. So we use field extraction a lot of times. The way Splunk looks at data is a key value pair. So like this equals this, this equals this, this equals this. Well, sometimes the key will be a value, and the value will be like a colon separated list. So you might have
Bad log writers. They're evil people.
Yeah. So it might be a colon separated
Everything
list.
should be JSON.
JSON, not JSON.
That's for Tal.
Yeah. So anyway, so you might have to do some regular expression, to maybe do some extraction out of the field. So you can kind of teach Splunk. If you see this, extract this thing for the value, and then lookups. If you want to go do an external lookup, either maybe you have a CSV file that will map like an error code to some friendly name, or even what's cool here is you can do lookup against SQL databases as well. So if you have this, if you have some SQL data over here that you don't want to bring the SQL data into Splunk, but you want to have that SQL data augment or add value to what Splunk does, you can do some lookups there as well. Okay, so that's what a Splunk app is. Questions on Splunk apps?
Is that app store specific to your business unit, or is it actually community?
No, it's actually community. We just participate, as a company, we participate.
Yeah.
And actually, I do want to be very specific that generally speaking, the apps are free. If you put an app on Splunkbase and you think it's valuable enough that people will pay for it, you can't actually charge for it, right? So I don't think we have any e-commerce based around that on the site, the Splunk-based site, but we will eventually have that. But you can always say, hey, look, this is what I have. If you want to go get it, you can download it here, and it's going to cost you X or whatever. But we typically, our groups, typically make sure that all the apps are free, and because it's a consumption based. So if you use the app, it's not free, right? It costs you to get the data in. But the idea is that we don't want to be a barrier.
Right. Okay.
Ultimately, like VMware, you charge for the size of the app.
Yeah. The
Yeah,
data
well,
that's
we
coming in,
charge
yeah.
for the size of the data that the app consumes.
Yeah.
But yeah, very similar, yeah.
Yeah. So anyway, yeah, I mean, more data coming in, and then we make money, and then you get value out of your data. Yeah. So anyway, all right. So we have specific Splunk apps for this industry. Do you want to come over here and do the app?
Yeah, I could. I just don't know how well it's going to work
I was
with
going to
hand.
give you my mics.
I don't think that's
Yeah, we can do that.
plausible. Anyway, we'll just talk about them first, and then
Okay.
you can be my keyboard monkey.
Quick question.
Yes.
If the data has been structured, go back to the JSON thing, then do you use that information? Is that easier for you to consume in some way?
Yeah. So
Repeat the
Wild's point on the JSON thing is that we have we have built-in data extraction for JSON. So you can, if your log data is JSON, you can pipe it to a command called spath, and it will automatically extract all the data and do it in a hierarchy format, which is the way JSON. So, but you don't have to do that.
The problem in general though is, I guess, vast majority is
No, I'm completely with you. So my attitude is, and it's an attitude I've taken with the Zen desktop thing, and I'm changing some stuff with the Zen desktop and Zen app. I don't want to artificially inflate data just for the sake of artificially inflating data, right? I want the data to be valuable, right? And I want to charge you for that data, but I don't want to duplicate data for no purpose, right? And a lot of times when you do JSON, you'll format it properly, right? And when you do that, that's white space, that's wasted characters, it means you're bloating the index for no particularly good reason. So if you're going to use JSON, I would use compressed JSON. I don't honestly know the answer to that question. I mean, I know that we've had some people come up with the UTF-8 and other things like that. It's typically ASCII. It'll get converted to ASCII, I think, at that point. So I don't know, like, if you did Chinese characters, exactly what that would look like. Well, the data, for most of our customers, the data, yeah. Yeah. So specifically in logs, I mean, we don't have a lot of, even Citrix, if you're using the Chinese language back, the logs are going to be in English. So actually, they're in English, which is really frustrating because the dates are all backwards, but that's a whole nother conversation. Not American English, which is really frustrating. Yeah. Oh, for you guys. So Splunk for server-based computing, that's the name of our group. The apps that I'm working on right now, we have Zen Desktop, Zen App, NetScaler. We have a Splunk for server virtualization. The idea is historically, I've always had this problem, where if you're in a large Zen App or Zen Desktop environment, there's so many layers to the cake, and there's so many things going on. And each component is typically monitored, alerted, and managed separately. So you're going to have the storage group doing its thing, you're going to have the networking group doing its thing, and you're going to have the Citrix guys doing their thing. And then the hypervisor, depending on how it came into the company, it could be a completely separate group altogether, or it could be correlated. The point is that there's so many different places that Zen App and Zen Desktop, or VDI in general, can break. And cloud services, software as a service, same concept. There's so many different pieces where this can break. So it's always kind of been the bane of the existence of trying to figure out, when a user calls in and complains, what is broke. So the approach that I'm trying to take is, at the level of you have vertical specific apps, Zen App, Zen Desktop, vertical specific apps, and then there's approaches where you have generic concepts, storage, networking, right? The idea is we wanted to create a Splunk for server virtualization so that you as a Zen Desktop customer, or you as a Zen App customer, or you as a View customer, or it doesn't matter what you're using, I shouldn't care what hypervisor you use. If you want to use Hyper-V, go for it. If you want to use Zen for it, go for it. My app, or what we're calling apps, should work the same regardless of the virtualization platform you choose. The same for storage. I shouldn't care what storage you use. If you want to use NetApp, use NetApp. If you want to use EMC, use EMC. The way that we do that is we create generic apps. So we have a Splunk for server virtualization. We're going to have a Splunk for server storage, or storage. And the idea is that we'll come up with a common information model, because a lot of these server virtualization, while there are some huge differences between the different platforms, the base concepts are the same. They all have hypervisors, they all have VMs, they all have virtual networks, they all have some concepts the same. They all have performance metrics. The performance metrics are generally pretty close to the same. They all have CPU, memory, disk, that kind of stuff. So the Splunk for server virtualization app is our first app that does this. It's cross-platform. It supports Zen Server and Hyper-V right now. It will very soon hopefully support VMware. The VMware thing's a little bit of an issue because we actually have a whole VMware app. Splunk has got a whole VMware app. So we're trying to, and that app was done before the server virtualization project started, so they didn't abide by the SIM, because obviously the SIM wasn't around, so we're having to try to backwards port that to the SIM. Some stuff that we have, actually UCS stuff, should be hitting Splunk base very soon. So if you're using, so if you're a cloud service provider and you're using UCS, or you're an enterprise and you're using UCS and you have Zen Desktop on that, on top of that, and you're using EMC and you're using, Hyper-V or Zen Server, or using both, because I personally think each hypervisor has a very good place in industry, and I think there's certain places where you should use Zen Server, and I think there's certain places where you should use Hyper-V, and I think there's certain places where you should use VMware. And I think it's perfectly realistic for a single company to use all three hypervisors. And this will provide a single interface for all three platforms at the same time. And it's actually, back to the Zen app and Zen Desktop, same concept, but we do it cross version. So with Zen Desktop, we support Zen Desktop 4.0 and above. All in the same interface, all with the same dashboards. There's nothing that you have to go change. It's not like you have to go, well, this is the Zen Desktop interface, and then if you have Zen Desktop 5.5, you got to go here. If it's Zen Desktop 5.6, you go here. Same with Zen App. We support, technically we support Zen App 5 and above, but if you have 4.5 with rollout 3, it should work as well. Anyway, so UCS, NetApp, EMC, AppSense. AppSense and Res, those kind of, I'm sure they're like, what the heck? And the purpose of those is because most large enterprise environments have got to have profile management of some sort, right? I'm using profile management very generically here, so don't get all freaked out, you AppSense and Res people. I know you do more than that. But the whole point is that these are critical parts of your infrastructure. And understanding what's going on with these critical parts of your infrastructure is just like everything else. I mean, it doesn't do me any good to solve the what I call the 2-hour, 5-minute problem if AppSense is thrown in there. And now you have another piece of it. Well, it's like, oh, I can do everything but AppSense. Well, I mean, I've not solved your problem, right? I've solved part of it, but not all of it. So I want to be able to solve all of it. Cloud Stack and OpenStack, those are both up-and-coming products, a lot of industry around that. I don't think we have, the different schools of camp. It's almost like early hypervisor days and like blood battle going on there. But anyway, so these are the apps that we have. Can we share them?
That's a quick. Oh, what do you want?
What do we do?
I don't know. Do you want to go into apps?
Actually, how much time do we have? I want to leave a lot of time for questions.
I think we got like 20 minutes.
She's not looking at me.
20 minutes, I think.
20 minutes? Okay. You're going to get these slides, so I'm not going to read them to you. You have all this information. This is kind of, this is just a slide to tell you that what we're doing for Zen App, or Zen Desktop and Zen App. Again, this stuff I think I've already told you. The support that we have. And nothing that I did, nothing that we're doing in the Zen App, the Zen Desktop, the UCS, nothing actually we're doing in any of these apps is not something that you probably could have done on your own. BriForum, typically pretty smart people. So there's not really anything you probably could have done on your own. But Splunk is a really, really powerful product. And with any powerful product, there's a level of complexity. So typically, if you were just to go download Splunk, the free download that Jason showed you earlier, and installed it, you probably wouldn't get very far. Right? You'd see the search bar and you'd be like, great, what do I do? Like, how do I get data started? I mean, I don't know, I'm sure, how many of you have actually downloaded Splunk before and had that same experience? We know this, we're trying to fix it. Splunk is really powerful, but if you just download Splunk and look at the search bar, it's not going to do anything for you, right? You have to actually get data in. And then after you get data in, you got to learn more about the search language, and you have to do dashboards and stuff like that. Super powerful, but there's kind of a high bar to entry. The point behind the Zen App, Zen Desktop, the Splunk for UCS, all of these products isn't to give you a point solution, although you can use it as that. The idea behind these apps is to get you started, get you in the environment, give you automatically useful data. So you can go download Splunk, you install the Splunk for Zen Desktop app, there's documentation to tell you what to put where, and then you automatically start getting data. Years down the line or months down the line, depending on how fast you are, as you get more comfortable with what's going on with Splunk, you start understanding how it works, then you can start thinking out of the box. You're like, yeah, this dashboard's nice, but I'd much rather it did this. You can go in there, convert, change a little bit of XML, and you're done. The dashboard does what you want it to, and no one cares, right? Because it's your app. There's no schemas. The next time we do an upgrade, all your changes will be in a different folder, so you're not even going to lose your changes, right? So that's kind of the perspective, which is kind of the motivation behind these, is to lower that bar significantly, so it's much easier for industry-specific verticals to kind of have that entry into the product. Splunk for XenApps, Splunk for server virtualization. Let's just go ahead. So these are where you can download the apps right now. We have Zen Desktop, that's the URL, which is really long, and the XenApp, NetScaler. The Splunk for server virtualization. The Splunk for server virtualization, because it was generic, we actually created 2 downloads. One is the actual dashboard, and then the other one is the TA. And the reason why we did that is because you may not care about our dashboards. We're like, I don't care about the dashboards, just give me the data. If you just care about the Zen server data, you can download the Zen server TA, start running the Zen server TA, and then you can build your own dashboards.
Yeah, the TA is the collection piece.
Yes, Harry?
Can we just ask a question? These apps that you're building, are you building these data collection apps?
Yes.
With vendors, or you just in Microsoft?
So I try to do it with vendors when possible, right? Because I know we're trying to hire industry experts. So like my team, we have Jason, myself, we're both CTPs. We have a new guy coming in, Joel, he's a Microsoft MVP. We have Hal, which is a VMware expert, he's a V expert and a PowerShell MVP. So we're trying to hire industry experts so that we can understand, because to make the data collector right, you need to know the data. But even still in those situations, it's always best to go to the vendor because no one knows the data. No one knows the data better than the vendor. So I try with Citrix. We did a lot of stuff with Zen Desktop guys and the XenApp guys. The NetScaler guys we're working with their PMs to try to get their data. When we start doing AppSense, I'm going to be all up in your email, trying to figure out who to talk to about getting that stuff right.
So, and the apps do.
I'm sorry. Go ahead.
Really complicated with Splunk where people don't even know.
I'm sorry.
You already complicated with Splunk where
Oh, okay. So he's saying they already do it, some of it.
And then the apps are free?
Yes, the apps are free. And actually, depending on the size of the environment, the Splunk part can be free too. Like if you're under 500 megs, it's really up for grabs there. Let's go. Do you want to? Let me just show you real quick. You've already seen what Jason's done on the dashboards. So let's look at these apps. By the way, are all changing. So to be perfectly frank, I am no web guru. I don't know how to do CSS all that well. So these apps are all just base Splunk. There's not a lot of prettiness going into it right now. We're going to do official releases for XenApp v1 and Zen Desktop v3. This is going to include the Zen server or the hypervisor integration. It's going to hopefully include the NetScaler integration, as well as a kind of a refresh on the visual to make it more pretty. Prettier? Yes. My grammar is also not very good. Anyway, so this is kind of what I was talking about. These are dashboards. We've broken it down into different components. We have the environment. We have session statistics, which is basically information about the sessions. The one we're probably going to spend the most time on is going to be the user experience because typically speaking, that's what's most important to people. And then we have desktop performance alerts and reports. And again, these are just stuff that we built. You can actually do your own thing if you don't like what we've done. So, the environment is just a basic overview of what's going on. In your environment, will tell you how many sessions we've seen, how many users, how many virtual machines, desktop group information. So we'll have all the desktop groups. And again, this will work with Zen Desktop 4, 5, 5.5, 5.6. Desktop alerts. So in Splunk, you can create searches. And you can schedule these searches to run. You can actually have them run real time. You can have them run every 5 minutes, every hour, however long you want those to run. And it will. You can have it say if you do the search and you get more than like 4 responses, or if you do get a result, that's a problem. An example is we have the application crash or hang. So we look for Windows event logs and says, hey, if you see this Windows event and it's got this status code or this type. That's an alert. Go ahead and trigger an alert. So we have the alerts, applications, crashes, CPU. There's actually about 12, I think, by default. And you can see this here. I don't know. So these are the ones we do by default, and you can add your own, so you don't have to abide by ours. Application hangs, memory, CPU, disk, failed DDC registration, that's an important one. High disk I/O, that's another important one. If your ICA latency is high. So we have some standard defaults. We've talked to Microsoft, we talked to Citrix, and what do you think are bad levels? But all of that's customizable by you. So you may be in a situation where you have a lot of connectivity from overseas, so 250 milliseconds is probably okay for you, generally speaking. You can bump that up to whatever is a problem for you. And then this one right here is RDP or local. So if you have people connecting to VDI sessions using RDP or local and you don't want that to happen, you can get alerts. Session over time, sessions, so this is sessions over time and usage over time, so percentages versus just overall counts. All of this stuff, again, remember it's all based on text, right? We're just collecting textual data, and if you really want to get crazy and see what's going on, you can click this little link here. It will actually show you what the raw data looks like. See when
You can go up to the search box and press enter. I think you had to do that for some reason.
No, your computer's slow. Anyway, so this is your raw data, right? So it's all still there. Nothing's changed. Anything else on the environment thing? The other thing, we don't have time to go through all the click-throughs, but we also have the concept of click-throughs. So you can say, hey, when you see this data, I want you to be able to click through. So if I click the application hangs, it'll actually give me a detailed report of all the application hangs, the applications that cause the alert. Look, there's Wild. He's causing problems. The affected user and the times that those events happened.
And also,
Did I see a question back there? I don't know. It's very bright right here.
And also, it's important to notice also that 2 versions of Zen Desktop are coming in here. We don't care. Again, we don't care about the data. We don't care how the data was generated. 2 different types of totally different versions of Zen Desktop are reporting data in here.
So here's the session statistics. So this will just tell you, again, your sessions over time. Top users, top client IPs, top VMs. This is normally much more useful because you can see these. But this will tell you how many Android devices, iOS, Windows devices, Mac devices. And you can see those by highlighting it over. And over here you have client versions. So we all know how Citrix likes to update their clients on a semi-weekly basis.
Yeah.
And you need to be able to track those client updates, and you need to be able to figure out if we have, a lot of times there'll be a bug and you're like, oh, we have to get rid of that version. You can actually see if people are using that version. And then on top of that, you can also set up alerts saying, hey, if you see someone using this version of the client, you need to let us know so we can inform them that they're stupid. Because it's always the user's fault. User experience. So the idea here is I wanted to make the foundation for what you would call a capacity planning product so that you can actually try to figure out how your environment's doing as a whole, how much your users are effectively costing you, and how you can take the environment that you have now and scale it out to how many users you have. So you'll see that there's a chart up here. Obviously, big red X is bad, small green star is good. So you can see right here, this guy's having some latency issues. You can see what that latency is over time. You can also see that this guy's having memory problems, and not like thinking memory problems. This is also a big deal. On a VDI, having 33 IOPS per second on average is not good. The storage guy is not liking you right now. You are on the top of his hit list.
One of the things that's kind of interesting there is that you just said something which you have to know. That is, I'm sure, we're all smart, you're all smart IT guys, but that number, that magic number.
The 33?
Yeah, you have to know that. And so
Well, that's why it's in the app, right? So we've talked to the vendors and we've come up with what the vendor has told us are bad numbers, and what we know from industry experience are bad numbers. These numbers are customizable, but I know what you mean. Yes, you do need to know this stuff.
The numbers are customizable, but there's going to be hardware dependent. That is,
Always a
I
challenge.
wouldn't want you to build something in the, I wouldn't want you to build something into an app which then if I change the next generation server on the deal or with SAP.
No. Which is why, that's why we made a point to make the numbers customizable. So if you're in your, I mean, there's going to be stuff that works out of the box, and then we have numbers that work out of the box, but if you don't like those numbers, or you have like super fast disk or something.
It's not built in.
Yes.
I mean, the power of Splunk is that smart IT people could build the app, essentially.
Right.
Build the app.
And for the smart IT people, and the smart people you're talking about, I always pitch this as a starting point, not the end. For your smaller companies, this is more than enough for most people, so they can actually just download and never think about what's going on. But so the other thing I wanted to show you down here is we have all the data that you would see in the broker. So there's in desktop, if you go to the desktop studio, all the data you would see there is right here. But the really cool thing is this one right here, which is I want to see the view running processes. And what this will do is it'll show you all the processes that user has run in the last 24 hours, and then give you the top 5 by CPU, memory, and network, total I/O. So we can look here, just off the bat. I'm sure all of you know what that process is up there. It's the nasty antivirus product. Seems to be killing us on a memory footprint.
Yeah, but you're secure as a result.
Yeah.
Yes. So it only costs you 1.6 gigs of memory to be secure. You can also see that Internet Explorer seems to be, as we all know, sucky. And down here on the IOPS, you can also see that our antivirus, on top of sucking the life out of our memory, is sucking the life out of our I/O, which is what they do. So it is what it is. Anyway, so it's just a useful data point. Any questions on this?
So all this data is being collected through WMI and Perfmon, all remote, there's no agents?
No, it's not agentless, please, no, not agentless, not agentless. I think that's fiction, but that's a whole other story. There is actual, we actually have, what we did is we installed the Splunk Universal Forwarder that Jason was talking about earlier, that goes on the VDA, and then we have what we call scripted inputs, or inputs that say, this is the data you want to collect. We have a native Perfmon collector, we have a native WMI collector. We do actually use a PowerShell script to collect the ICA statistics. And there's a reason for that we're going to fix. So in the next version, I'm hoping we won't even have any PowerShell scripts running on the box at
So
all.
what's the impact of your collectors?
I'm sorry?
What's the impact of your collectors?
So it really depends. I mean, obviously, it always depends. But we, I think on average, collecting Perfmon data every 60 seconds in the ICA, so Perfmon data, every 60 seconds, ICA data every 60 seconds, and EventMon real time. I think we have about, I'd say 3 to 4 or 5% is what we see, CPU-wise, and that's over time. So what happens is when we're collecting data, obviously we spike, and then when we're not collecting data, we're kind of coasting.
Essentially, we're trading off here space and CPU in some sense.
Say again?
Well, there's also a space issue, right? I mean,
Disk space? Or
well, no, I mean that's gonna disk space is IOPS to disk is gonna.
all right, so I can categorically tell you we do not do any IOPS. Physical disk
So
IOPS.
then it's an in-memory database.
Yes, we don't do any IOPS. I go out of my way, specifically for the VDI and XenApp, not to touch disk, ever.
Good.
Yeah, I think that's taboo.
So how much space do you in the VDI scenario?
So the memory footprint is probably our biggest impact, depending on how much data we're collecting and how many processes we're running. You can get up to 120 megs.
And also, it's important to note, like,
on 120 megs for what?
The Splunk process, if you look at Splunk D, it's going to be taking about 120 megs of RAM.
RAM.
All right.
So,
But
it starts off about 70 or 80.
That's not so big though. I mean,
It is when you've got these idiots putting 512 megs in their Windows 7 64-bit machines.
yeah.
No, it doesn't, but they do it anyway, because that's what HP says to do, and that's what Dell and everyone, we can get you 200 VMs on a hypervisor if you give them 256 megs of RAM.
Yeah, but to this point, it's something very important to remember on the universal forwarder. Like I said earlier, it's very dumb. It doesn't do anything unless you tell it to do something. When you download an app, we're giving you a set of rules or a set of things for that universal forwarder to do. If you don't want it to do all of that, you can strip it out, or if you want it to do
If the data's
more,
not useful, you
can.
can say, I don't want that, and you can just turn that, you can flip that switch off. Right?
That's a big reason why it depends.
In the context of the AV people, right, where, so what basically happened there was about the sensor, I assume, I don't know what Microsoft did, but the notion of forward, that, you have this instance per, a lightweight instance per guest, essentially, and then one blob per hypervisor, right?
Mhm.
There, certainly in sensor, there's a lightweight shared memory transport between guest and host, which if you're privileged enough to get hold of it, you can do that, and then you don't have to do I/O using network, which
Yeah.
is going to save you a shitload of interrupts and a lot of stuff.
All right. So, I mean, there's a lot of stuff we wanted to do in regards to that kind of stuff. Actually, we've had some issues. It seems from the hypervisor world, this data is hard to come by in regards to, where do I go to find out, the client, the tools version? Do I look at the hypervisor? Do I look at the VM? And so getting that data to transfer. So with Hyper-V, we actually could get it from the hypervisor, but there was one we actually had to get it from.
Well,
No,
the
sir.
nice thing with the nice thing with Hyper-V is that the enlightenment code, the drivers for Linux VM are now open source, right?
Mhm.
You can go and get that, you can figure out how to do it.
Yeah. So, I mean, there's some work to be done there, but typically these are like little tweaks and we can adjust them as we go. So if we're collecting something that you don't think is useful and you only want to collect it like once every 10 minutes and we're collecting it every 60 seconds, it's really a config file. You change it in one spot and then it automatically deploys from there.
And another point to note is this universal forwarder, sometimes it's a one-to-one, like in a VDA environment, you put a universal forwarder on each VDA. In a VMware and a Xen server environment, you have one universal forwarder collection for multiple hosts, which means in multiple VMs on those hosts. So it's one to many. And then things like that are doing syslog natively, like NetScaler, there's no universal forwarder. You just say, pipe that syslog data down to Splunk, Splunk receives it, no problem. So it varies on how it does it.
So you have this kind of hierarchical architecture that sat inside the server, a bunch of VMs. One blob per server now is going to collect all the VMs on that server, and it's going to ship it back up to the Uber Splunk, right?
Yeah, well, so that's the way we have to do it right now because the universal forwarder, I mean, although we could get it to work in Xen server and we could get it to work in VMware, it's generally just taboo, right? You don't want to install something and effectively DOM 0 or in the management VM, right? It's like a no-no. So the only way to collect data from those particular hosts or hypervisors is to have basically central polling, which we all know polling doesn't scale, right? But that's the only way to do it. So the idea is when you have a Xen server, so what we'll do is you'll have one collector for pool. So you'll have one VM, lightweight VM, that is responsible for monitoring a specific pool. And then you'll have one for each pool.
And then the Uber Splunk collects from them.
Yep. So the endpoint, the end user doesn't, or the consumer doesn't see the problem, right? They don't see the fact that there's multiple collectors.
How does that kind of intermediary collector scale?
It scales as much as you want it to go. I mean, there's no, because they're not they're not tied to each other, right? So the idea is that if you're going to have, we'll take Xen server
Just throw everything in one Uber index?
No, so the way it works is that you would have it send to, it would have the same config as everyone else, right? So you could say this forwarder has a list of 10 indexers that it sends data to. What it'll do is it'll pick one, and there's a load balance algorithm that says you need to go to this one. And all the indexers, all the forwarders would do that. So you would have 10 indexers. You change a config file that says this is the index that you're supposed to go to, or this is the list of indexes that you're supposed to go to, and it will just send data to that. If that indexer goes down, it'll swap over to another indexer and say, okay, this guy's down, let's go to this other guy. So that's kind of how you do it. And eventually what it'll do is it'll load balance the number of forwarders to the number of indexers. But one indexer, if it's a well-built indexer, like, and when I say well-built, you got to understand, we work on commodity hardware, right? So a well-built server is like 8 cores with 8 gigs of RAM and like 8 disks.
And do you support crypto for the log data?
Yes, but obviously that has impact.
Yeah.
Yeah, yes, you can SSL the, you can do encryption, and I think you can SSL the data as it goes by. Like you can either do a pipe encryption, or I think you can actually, and I know you can encrypt the data on the indexer itself, but again, that obviously has an impact, of course.
You can also
Unless you
mask-
get that one SSD guy that says, oh, I can give you a zero impact.
Encrypted SSD.
Yeah.
Yeah. You can also
I love
mask
that.
the data as it comes in. So if you're collecting credit card information, like one of your logs has credit card information for some reason, you can tell it before it stores it to mask out, so you never store
So you can
sensitive
hash
data.
out passwords and stuff
Yeah.
like that. So when it goes into the index, you don't actually store the password, you store a bunch of hashes. Because we all like hash. So the ICA latency right now is collected on the VDA or endpoints. So in the case of Zen app, it's actually collected by the server. In the case for Zen desktop, it's actually collected by the VDA. Because that's the only, without having a collector on the endpoint, which is near impossible to manage, the only place that we can actually collect the ICA data is from the VDA. So right now there's a PowerShell script that runs on whatever cycle that you tell it to run that collects the ICA statistics and stores those in Splunk.
Okay, we'll take any more questions up front. We have to clear the room now, so
Oh.
thank you for coming. Appreciate it.
How you doing?